right, Haley, we're back on. I just dropped my iPad, which may or may not have caused the thing. I think it was just a coincidence that my video stopped at the same time, but whatever. Anyway, number 10 and 11. No, 9 and 10. 9 and 10 are both logs, and here is the rule for log, and I will eventually write these all down for you, but here they are. Log base b of u. His derivative is 1 over u ln b times, I'm going to say u prime. They call it du dx, but that's what the rule is. Okay? So, follow the rule. Follow the rule. Okay?
So 1 over, what's u?
Now here's the problem. Let's figure out what u and b are for number 9. What's the base?
10.
10.
Yeah.
If there is no base, the base is 10. So that's what 10 is. That's what b is. B is 10. And u is this junk right here. So I have 1 over, I repeat u, which is x squared plus 3, you betcha, times ln of 10 times u prime, and u prime is 2x, but I'm going to lump him on the top. Can I do that?
Mm-hmm.
And I'm going to get rid of him there. Okay, so times u prime, and that's just what he is.
That's just it?
That is all.
2x over x squared plus 3.
Make sure you put parentheses around your x squared plus 3, so it doesn't just look like the 3 is being multiplied by the ln.
Oh, 10.
B is 10.
What is b?
Okay? All right, you try number 10.
Let us do number 10.
You do number 10, and then we'll check him. Okay?
We'll figure it out, right?
You do number 10, and then we'll check
I
him.
believe in us.
I believe that we will.
Okay, Debbie.
Oh man, I'm gonna have to start bringing a jacket. I'm always confined to this little area when I'm recording, and these windows leak like crazy, and so it's starting to get cold
Yeah.
outside, so I'm gonna have to bring a jacket because I'm like stuck.
Yeah,
in
like
this
at the
corner.
beginning of the year, if your stuff like by moves windows, you're
They
hot.
they like
And then, like,
really
during the
leak
winter,
like
you get
crazy.
really cold.
Yeah.
Wait, does 3x just become 3?
Yes. Yes. On the top,
Yes.
but on the bottom you write them as 3x. Okay.
Logarithmic
All right. All right.
Logarithmic.
Hold on, I'm not done. I'm not done.
Okay.
Don't
Did
do
you
it
get an
yet.
answer?
No.
Number 10.
No, don't do it yet.
Logarithm.
I'm not gaslighting you.
Nope,
That
you
is a
make your
word.
worksheets for a reason.
Logarithmic differentiation.
No,
Okay.
that's like cuspid. It's just not a thing.
Cuspid is a word. It's in the book. Oh my gosh, you guys are great. It was literally in the textbook, except it's not spelled. It's not spelled C-U-S-P-I-D like I thought. I thought it's C-U-S-P-U-D. Cuspid
You have to go on.
instead of cuspid.
Oh.
Whatever. All right. Did you get
No.
1?
Wait,
No.
Why do we have to do it?
No, I'm almost done.
Okay, go.
Just wait a
I
second.
am so confused. I was like, why did she say no?
She says
No.
no. You can't give the answer
Why
yet.
do we have to do
I
1x
forgot the
twice?
two.
Tell me the answer until. Okay, I'm good now.
Okay.
Okay. Did you get 1 over 3x times ln of 4
Yeah.
times 3, but the
No.
3 goes on the
No,
top.
I did not get that. I have a 3 on top.
She has a 3 on top.
And not on the side. Right there, like that. That's what you got. Can you reduce the 3s?
No.
Yes, you can. Yes, you
No,
can.
you can't.
Yes, you can.
No, you
Yes, you can.
can't.
Ha!
No.
Yes, you can.
Because this is one chunk at the bottom, right?
No.
Yes.
It's
There's
not.
just
It's not
X,
tracked because
L,
there's
and
no
4.
plus, so I could do 1 and 1, right?
Why?
Do you guys remember? Do you guys remember?
Kinda wrong if we don't.
No. Do you guys remember when we did when we talked about ln of 3x? Let's talk about him real quick.
It
Yeah.
doesn't specify that you need to simplify it.
Sure.
It just says.
But just going back, like that whole cancel-y zippity-doo thing, when we have ln of 3x, it is 1 over 3x times 3, right?
Oh, yeah.
Yeah? Which is going to cancel, so it's just 1 over x, right? You remember when we drew that conclusion? So if it's ln of 5x, or ln of 1/2 x, or ln of whatever constant number times x, it's just going to reduce the derivative to be 1 over x, right? That's what it will be.
X.
Does that make sense?
Equal.
For the same reason, like log base 4 of 3x would have been the same as log base 4 of just x, or log base 4 of 5x, or log base 4 of 1/2 x. All of that stuff is going to end up canceling to be this junk, right?
That makes so much sense.
Yeah, that makes so much sense. All right. Okay, logarithmic differentiation. Okay, this is stuff that we could take the derivative of naturally by doing like the product rule right here.
But we don't want this.
Right, but we don't want to because
We take it times ln.
doing logs of stuff makes it easier. So what we do, are you watching, Chase?
We take the y side times ln.
Chase, are you watching?
Times ln, and then we just do the ln.
We do ln here and we do ln here, right? We put ln in front of both sides. So I have ln of y, but then this is multiply and I'm going to split him right here. Okay, multiply means add. So he will be ln of x
Times ln of that
plus ln of that stuff, okay?
I wrote down a plus.
And this guy is this stuff to the 1/2 power, right? So it's like 1 plus x squared to the 1/2 power, okay? And if you guys want to go ahead right now and do the 1/2 here,
Can we just divide by ln?
that would be great. No, no, no,
At the end, though.
no, not quite, not quite. We take the derivative and the derivative makes the ln go away, right? Yeah? Okay, are we good so far? LNs allow us to break things apart, and that makes it really nice. Got it? ln allows us to break things apart. Okay, what's the derivative? Now we take the derivative. We haven't even done the derivative yet.
1 over y dy dx
Derivative of ln y, 1 over y dy dx.
Wait,
equals 1 over x
Equals
plus.
1 over x plus. The 1/2 just chills.
So
The derivative of
2x
that.
on the top
Yeah.
over
Is 1 over
2
1 plus x squared times the derivative of 1 plus x squared, which is 2x. But I'm going to put the 2x on the top.
Wait.
Like that. Yes,
Okay,
yes,
wait.
yes, yes.
Wait, where did we get the number
There's
2
a 2
from?
on the bottom.
no,
X squared.
there's not.
1/2.
Oh.
X squared.
Oh, you left the 1
Okay,
out in front.
are we
Sorry.
confused thus far?
No, you left
No.
the 1 out in the front.
What
Wait,
can I
shouldn't it-
what can I
shouldn't it
fix?
be in its own separate parentheses on
Yes, so
You
so
didn't already put it
technically
in the
technically
box?
yep,
Get rid of the
technically he's
1/2.
like this, right? If you want to do that way,
Yeah, but
right?
you-
And I went ahead and put him on the top, so 2x like
Gave him
this.
a-
Can you do that to the 1/2?
Okay, now can you take 1/2 times 2? Can these two go together and cancel?
Yeah.
You betcha. Yep, they can.
No.
So I've got 1 over
You have
x
to multiply the y
plus x over 1 plus x squared. Yeah, that's what he is.
Hold
Okay.
on.
over. You have to multiply
On that
the
side,
y.
I've got 1 over y. Yep. And now I want just dy dx by himself. So I have to get rid of the 1 over y, so I can divide by 1 over y, or multiply by y. So this guy multiplied by y, but then,
You gotta plug it in.
actually,
We don't have to plug it in.
let's just leave him.
Yes.
Because, and here's my only reason why, because if they give you like points to plug in, a lot of times they will give you the x and the y, right? So you wouldn't necessarily have to plug or like change y to x. So yeah, let's just leave him as y. Let's just leave him as y. I'll let you do that.
Yay.
Y times 1 over x plus x over 1 plus x squared, and that stuff, and that is it. Okay? Good?
Great.
How about that?
No.
What? Okay?
No.
I'm not ready yet.
I'm confused.
Do you want to try 12 on your own?
Yes, we do.
12 is harder than 11.
I don't know.
We should have done 12 first and then had you do.
Try it. Try it.
Try it on your own? Okay? You want me to get you started?
No.
Yes.
No.
Yeah? Okay, don't listen. Plug your ears. Okay? All right, ln on both sides.
Yeah, I got that.
This junk is to the 1/2 power,
Potatoes.
right?
All of it?
Yep,
just
the
subtracting
whole
it.
thing.
Sweet potatoes.
I'm going to bring the 1/2 down in front. So I've got 1/2 ln of that junk, right? X minus 1, x plus 1. Okay? Now here's the deal. Divide means
Yes.
subtract. So I've got 1/2 ln of x minus 1. And then what?
1/2
Sweet
ln.
Minus, yes, the 1/2 goes to the bottom as well. So don't forget that 1/2 goes there. Now you're ready to take the derivative. Okay? Can you handle it from here?
Yeah.
Basically, just
Maybe I'm lost again.
without
What am I doing? Oh,
Taking the derivative. Yep, yep.
Do I leave
So
the
that's
1/2
how we have it
alone?
broken apart.
Do I ignore the 1/2?
The 1/2
I
goes
thought you
away,
were
right?
wearing a glove, like a plastic glove while you were eating your sandwich. I'm like, okay, that makes sense.
You.
I
It
know.
sounds
What?
like
What?
liquid.
Does the 1/2 go away?
I'm also wearing a plastic
Um,
mouth guard, you know,
no.
to protect my teeth.
So why did you subtract it?
That one.
Do you put it on the bottom, the 2?
Wait, does division mean subtraction?
Yes.
So
So that means
If it's
I guess
1
that doesn't
over
mean
x
then
minus
what
1,
you need.
it'd be 1 over.
I bet different points have different.
2x minus 2.
2x minus 2. Yeah, if you want to distribute it through, that'd be fine. Yep. You betcha. Yep. Okay, you get an answer. Try to get an answer.
My tab will run.
Now we take the derivative of all of that.
So right here,
Yep.
right here.
You tell me when you're ready for me to go.
I'm not ready for you yet.
Okay, you try it on your own.
You are.
You're doing a good job.
The half goes away, right? Because no. He stays.
Yeah, let's put it on, I think, on
Are we what?
Just writing the y, or do we have to put the?
You can just put y.
Comature, wait. Come back,
Is
Comature.
that real leather?
So this guy,
What?
does he become 1 over x minus 1?
No.
Half over
1/2 times 1 over x minus 1.
Is it? I don't know.
times 1 over x minus 1.
Finder.
Because the derivative of
The
x
whole
minus
thing.
1 is just 1.
Okay. And then minus another half.
I'll leave all my homework on this clipboard. So where did he go?
What do you mean?
Right here.
To the
To
bottom?
the bottom. Yeah, so 2x minus 2 or whatever it is.
He's smelling
I gotta know what type.
Alright, are you guys ready? Did you get it?
No.
No.
I think I'm lost. But I got an answer.
You got an answer? Okay.
Hold on.
The really nice thing is that when y is by itself, you always know it's going to be 1 over y dy dx on that side, right?
Yeah.
Log
So is it
differentiation.
dy dx is equal to y times 1 over 2x minus 1
About Thanksgiving.
minus.
They're doing it.
We do this
right
like
now.
every year, something.
No, not last year. Last year,
Coacher, can
We
you
did
look at
nothing.
this? Did I do this wrong?
because we were in trouble.
Are you done?
Our class.
I think I'm
We're
done.
going to check it.
I was
I know.
in Disney World.
No,
Having
Disney
the
Fair,
best
let me
time of
just
my
check
life,
with
and
you.
now
was.
I'm
I
not.
think I did it right. I think
You
I'm
were
gonna
in
parentheses
zero?
in my spot.
Alright, you guys ready?
Yeah.
Okay.
Put my 2 over
L and y is
I heard the 0.
1 over y dy dx. Yeah? Equals. What do you do with the 1/2?
Just leave it.
He just sits tight. 1/2. Okay? Now I do the derivative of this guy. Derivative of that is 1 over x minus 1 times the derivative of x minus 1, which is just 1. Okay? Minus 1/2. Oh, shoot. I forgot an ln here. Did you guys see that? I forgot an ln there. Okay, you had an ln. 1 over x plus 1 times the derivative of x plus 1, which is 1. Okay, now I'm going to, yeah, you can distribute this 2 through right here.
What?
I'll do a different color.
2x minus 1 minus.
So 1 over 2x minus 2 minus 1 over 2x plus 2. And I'm not going to combine those. Oh, then you got to multiply your y over. So this stuff times y. Let me get rid of my,
Just put the y at the end. Slap her on the end.
just slap the y on the end. Sure, I could.
Y.
dy dx.
That's beautiful.
That is beautiful. That's not bad.
You're beautiful.
They're like.
Perfect.
She just looked at me, she's like,
Okay, good. That is, read that again, log differentiation. You're using logs to help break it apart, and it makes it really nice, okay?
Label what we're doing
I
under
like them.
Versus, okay, versus, if I were to just, we could do this with what we did last chapter, except it would be what?
Can you help them make
really
it?
difficult.
It would be really difficult.
Question.
It would be the quotient rule inside of
A
the chain, right? To the 1/2 power, it would be a quotient inside of a chain. Which is not
Yeah.
impossible, it just would be really disgusting, right? Okay?
Long.
Yeah, and you would end up with the same answer, but it probably would be like simplified differently, right? Like it might be like one piece together, but really disgusing. So, whatever. Anyway, alright. E to the u. What's the derivative of e to the u?
Do you need that one or do you need
No, I know this one.
E to the u times u prime.
E to the u times u prime.
Find that or do you
No.
know that? I know that one.
Hit it like really soft.
E to the u times u prime. So,
That one's
the
good.
derivative of e to the 3x minus 1, or minus 2. Luke, 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 you gotta be quiet. These boys need to know this.
Still like shouts. Yeah.
Okay?
Try to go down
So,
here.
we
Alright.
keep it that the same, but then we take it times 3.
So,
3.
e to the 3x minus 2 times
3.
the derivative of the inside, which is 3. Okay? And I simplify that as 3e to the 3x minus 2. Got it? And we could write that as like y prime equals that, right?
Well, yeah.
What?
Yeah.
Yeah.
What class?
Or dy dx equals that, or whatever it is, right? Okay?
Why is it? What happens when there's just a
She's
7?
in Cleveland
Okay,
now.
what is the rule for when you have like a number to an x power?
What did you do
I don't know.
Comes a 1.
No, it has like an ln or something in it. Do you have the rules?
Chemistry?
Reese.
Yeah, she drops chemistry and AP and.
I need to read 3D. I don't know the rule first.
Give me my leather.
Give me my leather.
This is pretty. Did you already have this?
This is new. School, but
Like, but you.
How's the bottom of my shoes looking?
Calc.
Very nice. I got these in clearance. They're pretty
Can I do
cheap.
that one when you're okay?
Those are
Well,
my
not for the
favorite
purposes of you, but.
I love how you didn't say they're pretty good. You said they're pretty good.
Okay, they
Wait,
call
shoes.
it.
I was jealous you
Yeah,
could just put a week with that.
Like, you don't really care if your shoes are super
Oh my
comfortable.
gosh.
Sometimes I wish I had smaller size feet, like Jalen size feet, so that I could just buy little feet.
Let's call it b to the u.
That was
She's
me.
fine.
Anyway, I want the size of foot that Jalen
All right,
has.
here is your when you don't have e to the x power. So b to the u
These are so cheap.
is b to the u
Cheaper than big kids' shoes.
ln of b
It's
times
not pretty
you wear
bad.
u prime.
Just like, how, I want to see how big
There
it
you
is.
go. That's the rule for.
that tiny.
No,
Yeah.
they're not tiny.
It's just basketball shoes that I have to
These are
Okay.
10s, I think.
This is the rule for a base other than e.
But I need a 10.
Let's do 7.
These are 12.
So b to the u is like your base is 7, x is your u. So 7 to the x power times ln of what?
Go me, what is B?
These are 13.
A base.
B is your base, and your base is 7. Okay. ln of 7 times
Wait.
These are 10 'cause Maggie runs.
u prime.
Running off.
What's u prime? 1.
Come
So
on, we
just
gotta slow down.
I usually will.
7 to the x ln of 7. There you go.
I usually wear 12 foot dudes.
That wasn't bad.
That was bad.
But now you have to do.
Just kidding, I wasn't paying attention.
ln of 7
B to the U.
times nothing.
In sign.
Wait,
Wait, can you go over? I gotta see the rule.
Oh, here's the rule.
if the prime of 7 is 0, then if you take
No,
out 7,
no, 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 no.
Yeah.
U prime. U is your exponent, not your base. Yeah? You betcha.
These are so comfy. And they're
You
like-
betcha.
they're like only 10
Okay.
dollars.
U prime.
So 7x
They don't really last.
ln of 7.
7x ln of 7. Yep, you betcha.
You betcha.
But they're comfy.
Because
betcha.
because the last part
Okay.
is 1.
Why are we doing tangents?
These are
Yes.
like,
Yes. Yes.
How does that?
How does this one work? 15. How do you do this one?
Hold on.
You don't.
Hold
you
on.
Don't do it.
Because it's like
I've had these shoes for a
technically.
while.
Hold on.
Like a long time.
Yeah, what size of shoe do
It's
you wear
technically what?
These are 13.
in men's?
Women.
Well, what's that in women's?
15.
It is a product.
Oh,
Even though it's to the x power, the x is the
Uh-huh.
15.
Uh-huh.
So
Okay.
great.
Yeah. So 15 is a product. Product rule. F prime G, G prime F. Do you guys want to try it on your own?
Yeah.
Yeah,
Oh my god, you're
that's a 15 in women's. That's a 15 in women's.
Actually?
I'm pretty sure.
Yeah.
Well, okay, Luke, you gotta go somewhere, but not here.
Okay, we're doing the product.
You need to go away.
Sorry.
Okay,
We can't
what
focus.
number are we on?
Okay, we're good.
15.
We're good. We're good.
How do you even do this?
We're focused, Cometry. What do you
15.
mean? We are focused in.
I got kicked out of Buckleman's because Buckleman's not here.
Right. Yep.
Who's there? Who is
Go
it?
away.
Kelly! It's Kelly!
What's your first name?
Oh wait, it
15.
Not Susan.
When it's
Yeah, e to the x is e to the x. Yep.
UIDX.
I don't know why I thought it was
still has
Buckleman's.
an X.
Susan Arms.
I don't know how
It wouldn't
to
just be
simplify
Susan
it.
Arms.
It has,
Does not sound right.
Yeah, it's not like Red Arms.
What?
It won't simplify much.
so 13 is just
The only thing
same
I would do to simplify is get rid of any parentheses that you have,
Yeah,
which really just makes
So
it go away.
see what
G
you
prime, G prime, G prime is EDX.
It's getting easier slowly.
Slowly easier. Okay, we'll take it.
X cubed. Okay. So we
Okay.
got- Should I put e to the x in the front or behind?
I put 'em in the back.
Squared,
Okay,
yeah.
so I did too. So 3x squared e to the x plus x cubed e to the x.
Yep.
Yeah?
Yeah.
Yeah!
Why do we have tangents? I don't
Uh,
see those actually.
Cometry, why did you do y prime? We never do y prime.
What?
We never
Okay,
do y prime.
sure.
Wait, does G prime say that? Why does G
I
prime say the same as G?
definitely did not do whatever
No,
I
it
did
has, it just
right.
That is all.
It does not just does.
Yes, it does. Just does. How does it not just does?
Because only.
No, it does not just does.
Yes, it does. What would it be then, Josie? What do you
No,
think
no. It didn't change. Why didn't it change?
Because the derivative of
The e to the x. Why did it not change?
Because e to the x.
The derivative of e to the x is e to the
Try
x.
it.
Okay, the derivative of e to the u is e to the u times u prime. Okay, e to the x times what's the derivative of x? There you go. So it's the same thing.
It just does it.
There you
It
go.
just does.
Okay,
Got it.
16. Are you guys on 16?
Wait.
Okay.
Wait.
Killing me.
I know I can't
X
muscles around there.
Just
what the muscle is.
X plus x to the
Why?
third.
Just is. Okay.
No, because
Next
guess what,
one.
Jen? I was right about the alias so as.
Why?
Because I
Okay.
was right.
Why?
16.
Don't-
I'm not gonna do it yet. You do it.
Do it.
You do it.
I don't.
You do it. E to the tangent x. This
What
one
is
is
it?
easy.
Negative cosine?
It's e to
Or
the u
cotangent?
times u prime. So
Yeah.
it's e to the tangent x times
What's
which is
Derivative of
secant
tangent x.
squared.
Secant squared.
squared? So secant squared e tangent to the x.
What?
Yeah. But put an x on your secant squared. Secant squared x.
Yeah.
E tangent x times, what'd you say the thing of?
Secant squared.
Secant?
Uh-huh.
SC, SCS?
SEC. SEC.
SEC.
Do we have to do more projects?
Secant squared? X?
Beautiful. That was actually nice.
That was not bad.
I
That
like
one's
that
not
one.
bad.
Wait. Secant?
Can all of them be like that?
Secant squared.
Okay, boys, so you watching? Did you get it? Did you get an answer?
This?
Okay. So x.
Yeah, but x just becomes 1.
No.
Squared x.
No. Times the derivative of 1 or x, which is 1.
Times 1.
But then you don't need that part.
Did you just say that the x turns to y?
Okay. So derivative of e to whatever stays e to that thing. But then we take the derivative of the top. The derivative of tangent is secant squared x. And so, I don't know, some people put the secant squared in the front. I would probably too. dy
I
dx
did that.
equals secant squared x e to the tangent x. That's his derivative. Okay? Good?
What are we gonna do?
That's what he is. Okay?
Natural?
Good?
I saw that.
17 is not a product.
It's not decorated.
Can we do this through the product?
We're able to decorate.
What's the derivative of inverse tangent?
I actually have that one.
We only have 9 days till
I do have it. I have it.
Josie, there's enough going on.
1 plus 1 over 1 whole
Okay.
Because everybody
Here we go. Here's the rule for tangent. It is 1 over 1 plus u squared times u prime. So you can put the u prime on the top if you want.
That's a 1 plus
1 plus u squared over or times u prime. That's what the
That's dumb. I don't
thing
like
is.
that.
Okay? You can figure this out. This one's not too
Yeah,
bad.
I can do this one.
Yeah,
Actually.
you can do it.
U prime is 3x squared.
So technically it's
Over
x to the
1 plus.
Yep, so put your u's and everything where they're supposed to go. Okay?
That was really easy.
Can you do
I
it?
like that one.
So you add when you multiply exponents, but when
So
you
we're gonna write down all these,
parentheses, when it's that to that.
Then it's multiplied. Because that to the that actually means,
Can
Jayla,
I put the
like if you had
derivative
x
in
squared to the third, that means there's 3 of them. So it means this,
This and this. Okay, got it.
right?
Yeah.
So here you add, but here you multiply. Yeah.
Can I, hypothetically,
Yes.
put my derivative in front of my fraction?
Yes. If you really feel like your heart
You go
desires
for it.
it.
You go for it. Okay? So what's your u in this case?
X to the third.
X to the third. So 1 over 1 plus x to the third to the second.
6.
X to the 6 times u
What?
prime, 3x squared. So
That
you
goes
could lump
above.
him onto the top. 3x squared over 1 plus x cubed. Awesome. Or x to the 6, I mean.
Oh!
That is your derivative.
We'll do this next one when it's like.
It's really satisfying for inverse tangent because then it gets rid of, like, you don't, the the derivative of inverse tangent doesn't have a trig function in it, which is really nice. I like that. I like that. That's
How the heck do
okay.
you do the next one?
18
No.
is a
Chain.
chain. Yeah,
But we're not doing that.
it's a chain.
I know.
Okay, so for the chain rule, the outside is to the third power, so we just work on him. The 3 comes down in front. You leave the inside. This is what the chain says, right?
Sine
To the
negative first x.
second power times the derivative of sine, and the derivative of sine is something.
Cosine.
No, it's
No,
not.
inverse.
No, inverse sine. Inverse sine.
Here,
I
got
need
it.
the paper.
1 over square root of 1 minus u squared.
The derivative of sine is 1 over 1 minus x squared times the derivative of whatever, so that's
1
it.
over square root. 1 minus x.
Okay, now what would you do?
Wait,
Uh,
literally just plop that all
I would
together.
plop that all on the
just
top.
put-
Wait, and then
You
x
want the x
becomes a
equals-
1? Does x become a 1? Is that why we don't have the rest of him?
Yes, yes,
Well,
yes.
yeah,
Because
we
dy
have to find
dx,
the
yeah,
derivative
yeah,
of the
yeah,
inside,
yeah.
but then So it's just
Well, yeah.
There you go. That's what,
So 3 sine. to the
that's
negative
what
first
he
x
will be.
squared
That is what
over
he will be.
Square root of 1 minus
That's
x squared.
icky, actually.
Yeah. Yeah, a little bit.
Why
I
can't
think
these
that's a good
squares
stopping
just-
area.
comes and goes, yeah.
Yeah, a little bit.
Why
Good
can't the
place to
squares
stop.
just
Wait,
get rid
go
of the
back.
square roots?
Oh,
Three.
nice.
Yeah.
Okay.
I hate these things. These ones aren't that. I actually like
No,
these.
I
hate these. I like these. These are fun.
We'll do one of these and then we'll stop. And then you guys can do the other two if you so choose. Or
I
whatever.
so choose not.
Okay. Alright, 19?
Oh, Lordy.
No.
19,
So, like,
equation
we're gonna
given
have-
find.
Is that
What
a
if
word
I don't
problem?
really have
Equation
text?
given find. Okay, I know that we're talking about surface area because it says it.
What if I don't know?
And
the
surface
solution?
area of what? I will give
Cube.
you. What? Surface area of a cube. Okay, let's talk about a cube.
Wait,
You won't have to generate these by yourself, but here's a cube. Okay.
It's got 6 sides.
It has 6 sides. Yep. Let's label one of the sides. What do you want one of the sides to be?
7.
No, we gotta have a variable.
X.
X. Okay. Now, if it is a cube, then that means every single side is an X, right? X, X, X all the way through. All of them are X's, right? And we're talking about surface area. Okay?
Wait, it
So-
has 6 sides. It has 6 faces.
Yeah, it is 6 faces.
So 36 edges.
Right.
No.
Okay, hold on.
24?
No. 12.
Where do you get
Anyhow.
going?
Okay. What?
I was getting. Oh.
Okay, we're talking about the area of all of the surfaces. What's the area of this front surface right here?
X squared.
X squared. It's base times height, which is x squared. What's the area of this side surface right here?
X squared.
X squared. What's the area of the top surface right here? X
So
squared.
6x squared.
6x squared is the area of a cube. Is the surface area. So our equation is surface area equals 6x squared. That's the equation of the surface area of a cube. Got it? Okay, the edges of a cube. Okay, what did we name the edges? The x's of a cube are expanding at a rate of 8 centimeters per second.
DXDT.
That means what we're given is dx dt. The x's are expanding at a rate of 8. Do you see how that works? dx dt is 8. Okay? How fast is the surface area changing? What are we trying to find?
D
Surface dy
How fast is the surface area changing?
DSADT.
dsa dt, which is weird. Yeah.
Decide.
dsa dt is what we're trying to find, right? When each edge is 6.5, what does that mean?
That's the.
Each edge, x is 6.5. Okay, so now what do we do?
Plug it in.
Nope. Find the derivative. We gotta find the derivative, okay? Alright, so we go piece by piece. What's the derivative of SA?
At DSA.
dsa dt. Okay, what's the derivative of 6x squared?
2 times 6 is 12.
12. X
DXDT.
Wait, no.
dx dt.
Well, no, we can plug in the stuff on that.
Okay, 12x dx dt. Now we plug in.
Okay.
So we're trying to find dsa dt.
Times 6.5.
12.
8 equals that. But I don't have my calculator out, so.
Well, 12 times
12 times 8 is 96 times 6.5. I don't know what that is.
I don't want to do that in my head.
624.
DSA over
Is it cubed centimeters per second?
equals
Yeah,
24.
Or is it square?
No. Surface area squared.
Okay.
So we're doing surface area per time, right? Surface area is squared. So centimeters squared per what's the time?
Seconds.
Seconds. Okay.
Bam! Mic drop.
624 cubic or square centimeters per second. Got it.
Do the
Okay.
rest
Okay.
together
All right. There you go.
tomorrow.
We'll reconvene tomorrow. Good?
Can
Not
we
tomorrow.
take
Not
the
tomorrow.
test?
Or do you want to do tomorrow?
No.
What?
I'm gonna be so brain dead.
What's the schedule like? You know?
The schedule is I don't know. Tomorrow
Monday?
I know that we have 30-minute periods. Let me see. I know I have a schedule.
Mr. Stress says
Hold on.
it does not mean
Hold
that
on.
it's okay to say.
Yeah.
I'm just kidding. I'm just
Josie.
I chose violence. I'm sorry.
It was so funny when you said it in practice and Miss Wright goes, we don't say
Say
that
that
word.
about
And Chef
ourselves.
goes, what did he go? He like just like looked up at the ceiling. He was like,
What did
so
he say?
yeah.
I can't say it.
It's
It's
the
not
R
gonna happen.
word.
Yes, the R word.
Yeah, you said that before.
Yeah, that's the whole point.
Early out. 1 o'clock dismissal. Here we go. This is that. So lunch is the last period of the day. There we go. Perfect.
What?
10:50 to 11:20. We got 30 minutes. We can finish this, right?
Okay, that's horrible.
Possibly. Yeah.
Whoa.
Now the deal here is
Nice.
third period.
No, but if we finish it all, then we don't have to go back to it on Monday. We can just do whiteboards.
Yeah, whiteboard's Monday, and then we can test Tuesday. That
Or
would-
we
I
can
like
finish
that.
this on Monday, whiteboard on
No.
Tuesday, test on Wednesday.
No.
We want to get that.
I'm
Um, But third period, you guys know
We
that
won't-
one act is doing their thing, right?
Yes.
Yes.
Okay.
No, we're not here
Okay.
Monday.
Yeah,
No.
so why would we want to finish it on
Yeah.
Monday?
Never mind. We don't want to do that.
We want
What?
to
Why do
finish.
we want to finish it on Monday? Exactly.
Because we want whiteboards.
All right. Anyway,
We want
there's the deal.
whiteboards.
Goodbye, Haley.